In this section, we are going to learn something called the Pythagorean Theorem. While the Pythagorean Theorem isn't directly about graphing linear equations, it is a very important geometry concept that will appear in the next section of this unit and future math courses if you take more math. So the Pythagorean Theorem is something that can only be used with a right triangle. And if you are unfamiliar, a right triangle is a triangle that has an angle of 90 degrees. Right triangles often have a box inside them that indicates the specific angle is 90 degrees. So for example, a right triangle visually looks like this. And then here you'll have this box, and this box means that this angle right here is 90 degrees. Now, the Pythagorean theorem states that if you're given a right triangle, its two side lengths, we can find the other missing side length by using the following formula. A squared plus b squared equals c squared. So, what does this look like and what does that mean? Well, let's get into it. Let's start to explore some right triangle relationships, and as we're doing that, we're going to take a look at what exactly the Pythagorean theorem is and what we can use it for. So, given a right triangle, we're going to have the right angle right here, and then notice here we have a B, and a C in the Pythagorean theorem in this formula. And notice here we have three lengths, 1, 2, 3, and three variables, 1, 2, 3. So variables A and B, they represent what is called our legs of the triangle. And our variable C represents what is called the hypotenuse of the triangle. So our hypotenuse of the triangle is right here. Your hypotenuse is the longest side length of the triangle. And your hypotenuse is always going to be directly across the right angle, always. So whenever you're trying to figure out what your hypotenuse is, if it's not like that obvious, if it doesn't jump out right away, because sometimes triangles can be oriented in any way, so sometimes it can be kind of confusing when they're oriented in weird ways or weird angles. So if you always get confused, just know that the hypotenuse is always directly across from this right angle. And then as we see from the formula here, we know that C represents the hypotenuse. So that must mean this side length represents C in the Pythagorean theorem. And then we have the variables A and B. Those represent our legs. And our legs are the other two side lengths. So we have one leg here of the triangle and another leg here of the triangle. And for variables A and B, you can assign the variable A to this leg or the variable B to this leg if you'd like. You can assign either or variable. So I'm just going to say the variable A for this one and the variable B for this one. Alright, so now that we got that down, if it's not that clear, so what the Pythagorean theorem does for us is, let's say we have the side length B and the side length C figured out, but we want to know what the height of the triangle is, we're missing this part of the triangle. We can use this formula to solve for this side length, for this missing side length. But we'll get into those examples here. Off to the side here, I'm just going to write some characteristics of a right triangle. Alrighty, so some characteristics of right triangles that are at least important for this section of notes is that, as I stated before, the hypotenuse is always across from the right angle and is the longest side length. And another thing to note here is that the sum of both legs are greater than the hypotenuse. So if you add this leg and this leg, legs A and B of a right triangle, in order for this to be a triangle, these legs need to be greater than the sum of these legs. When you add these two together, that value must be greater than the hypotenuse. And then right here, let's get a visual. I'm going to draw a visual here real quick of what exactly the Pythagorean theorem is doing visually, so we can see what this means, or what this equation here is stating. Okay, so let's say we had squares. This more looks like a rectangle. But let's say on this triangle, we have squares. Now, I drew this triangle out weird, but that's because there's not a lot of room here. So this right here is our right angle. That's the right angle of the triangle, and I'm drawing out two squares. These look more like rectangles, but let's just say that they're squares. And then I'm going to have a square here on this side length. So because this side length is directly across the 90-degree angle, this here is going to be our hypotenuse. And the one thing you can think about is, if I wanted to find the area of this rectangle here, I would multiply this base, or this height, times the base. So base times height. And what is c times c? Well, that's c squared. And then here, for this rectangle, let's call this side length b. If I wanted to find the height, or now let's take a moment to see what the Pythagorean theorem is doing visually. So here, I drew out a triangle, and that the right angle of the triangle is oriented right here. So the hypotenuse of the triangle is directly across this right angle. So this side length right here, that is our hypotenuse. And these are our two legs. So since we know that this side is our hypotenuse, we know that the side length is c, because c stands for hypotenuse. But let's say, but how would we get c to be squared? Because we just have c on its own. Well, visually, to make c squared, we can find the area of this rectangle here. C times, so we have base times height, and c times c, well, that's c squared. And then here, this side length, we have side length. Let's say this is side length A, but I could also call this side length B. So just remember that A and B are interchangeable. You can assign whatever leg you'd like with A and B. But I'm going to say that this side length is A. And let's say if I wanted to find the area of this rectangle, I would multiply A times A, base times height, and we get A squared. And then here on this side, I'm going to assign this as B. To find the area of this rectangle, I'll do base times height, B times B, which is B squared. So what does this mean? Well, what this is saying is that if you were to take the sum of the area of both legs, so A squared plus B squared, if you were to add up the area of both A and B, the area of the sum of A and B would equal the area of the rectangle C squared. So that's what this means. That's what this is stating. All right, so let's dive into some examples. So for the following examples, let's find the missing side length of the right triangles using the Pythagorean theorem. So for example, number 1, I'm missing this side length here. Now let's draw an arrow directly across from the right angle. Well, this happens to be the hypotenuse. And what variable represents the hypotenuse? Well, that is the variable c. So we're looking for variable c in the Pythagorean theorem, which that is right here. And let's say that 15 represents our side length A, and this is our side length B. So all we have to do now is just directly plug in the numbers that we have. So we said A is 15, so we're going to say 15, but A is squared, so we need to square that. And then we're going to add 8, or we're going to add B squared, and B is 8, so we're going to have 8 squared. And C is what we're going to try. C is what we need to figure out, so we're just going to square C. So now, the first step to solve for C is I'm going to simplify the left-hand side. So 15 squared is 225. 8 squared is 64. We're going to set that equal to C squared. Now let's add 225 and 64, which that is 289, equals C squared. And now C squared isn't quite on its own. We haven't fully solved for C because C is squared. But do we know something that would cancel out the squared? Do we know something that's the opposite of something squared? That is the square root. So to solve for C, we're going to square root both sides of this equation. And what we get is C equals the square root of 289 is a perfect number, actually. It is 17. So this side length here is 17. Looking at example 2, let's first identify our side lengths of the right triangle. So directly across from this right angle, looks like 27 is our variable C, because that's our hypotenuse. And then 18 can be either variable A or variable B. Let's say that this is side length B. And then we want to know the side length A. So to set this up, well, we have A squared. We don't know A, that's what we want to know. So I'm just going to simply write A squared. B, we have a value assigned to B, which is 18. So I'm going to add 18 squared equals C squared is 27 squared. So now, to solve for A, I'm going to first start by squaring 18 and 27. So we're going to get A squared plus 18 squared is 324, which is equal to 27 squared, which evaluates to 729. And then to solve for A, I'm going to subtract 324 on both sides. So this cancels, and we get A squared equals 729 minus 324 is 405. Now to solve for A, I'm going to square root both sides. And we get A equals the square root of 405. And the approximate value for the square root of 405 is about 20.12. And that's your side length A. Looking at example number 3, we have the triangle 12, or we have this triangle with side length 12 and 12 root 2. Well, because the side length 12 root 2 is directly across from this right angle, this is going to be our hypotenuse, or in other words, the variable C. And 12, in the last example, we solved for A, so I'm going to assign this side length A and this side length B. So then in this example, we will be solving for B instead of A, so we can get some practice with everything. So let's start plugging in numbers. So we have a squared, which is 12 squared, plus b squared. We're trying to figure out what b is, so we're just going to write b squared. And then we're going to square c. And c is 12 times the square root of 2. So we're going to have to square this entire thing. So we're going to get 12 root 2, this entire thing squared. So let's evaluate. So we have 12 squared, which is 144, plus b squared equals, here, since we're squaring this whole thing, we're going to need to distribute in the squared. So we're going to square 12 and the square root of 2. Well, I'm going to write that out here. So we have 12 squared times the square root of 2 squared. Well, I'm just going to carry along. That's 144 plus b squared. And 12 squared, that's 144. And the square root of 2 squared, well, because we have this squared and the square root, these cancel, and you just get 144 times 2. And now, simplifying a little bit more, we get 144 plus b squared equals 144 times 2 is 288. And now let's subtract 144 on both sides. And we get b squared equals 144. And now, to solve for b, what are we going to do? We're going to square root both sides. And the square root of 144 evaluates to a perfect number, 12. And that's your missing side length. Alrighty, so for this last example, I encourage you to pause the video and try this one on your own. And assuming you worked through it, let's go through this together. So to identify our side lengths, let's first see what side length is directly across from the right angle. Well, it happens to be this missing side length here, so we're going to be solving for c in this example. And then when you worked on this on your own, you could have assigned a or b for this side length and a or b for this side length. So I'm going to just assign a for this side length and b for this side length. But if you assign b for this side length and a for this side length, that's perfectly acceptable too, as long as you got the same answer, because you can assign either or. So we said a is 5 root 3, so I'm going to say 5 root 3 squared plus 5 squared equals c squared. Well, 5 root 3 squared, that means we're going to do 5 squared times the square root of 3 squared. So 5 squared, that's 25. And the square root of 3 squared, well, the square and that square root cancels, so we get times 3. And then we're going to add 5 squared, which is 25. And that's equal to c squared. Well, 75 times 3, that's 75, or 25 times 3 is 75. Then we're going to add 25, set that equal to c squared. 75 plus 25 is 100, so we get 100 equal to c squared. Now to solve for c, our final step is to square both sides, or square root both sides. So we get 10 equals c. So that's our missing side length. All right. So for the last couple examples of the section, we're just going to use the Pythagorean theorem to solve some word problems. So for example, number 5, we have a lone hiker sets out at dawn, trekking 5 miles into the glowing eastern horizon. Then, determined to reach new heights, they push another 12 miles north into rugged, wild terrain. By the time they stop to look back, the landscape behind them stretches out endlessly. How far have they traveled from where their journey began? Well, we want to know how far they traveled from where their journey began. So let's box that question so we know what exactly we're being asked. Well, let's see what else we know. This hiker traveled 5 miles east. And then they also traveled 12 miles north. So using directions, I always remember never eat soggy waffles. We have north, east, south, west. So the hiker traveled 5 miles east and then 12 miles north. But we want to know how far this hiker is from their starting point. So let's figure that out. So I'm going to draw a line here. 5 miles east, and then the hiker went up 12 miles north. But we want to know the distance from here, the hiker's starting point, to here, where the hiker is currently at. Well, if we were to make this a right triangle, we can draw a 90-degree angle right here. And then directly across from this, well, the distance from the original starting point to where the hiker is at is actually the hypotenuse of a right triangle. We can make a right triangle out of this and use the Pythagorean theorem. Well, to solve for C, let's say this is side length A, and this is side length B. Side length A, so we're going to have 5 squared plus 12 squared equals C squared. 5 squared is 25, 12 squared is 144, so that equals to C squared. 25 plus 144 is 169, so we get 169 equals C squared. Now, to solve for C, I'm going to square root both sides. What we get? C equals 19. Not 19, 13. C equals 13. So the hiker has to travel, or the hiker is directly or exactly 13 miles away from where they started. Alrighty. So for this last example, I encourage you to pause the video and try this one completely on your own. And assuming you have given it a go, let's go through it. So we have flames are roaring and smoke fills the air. A firefighter races to the scene, needing the perfect ladder, long enough to reach a window 8 feet above the ground, but sturdy enough to lean safely just 4 feet from the blazing wall. Time is running out. How long must the ladder be to make the rescue? Well, let's figure out what's going on here. Let's draw a picture with the information we're given. So we don't really necessarily need this to solve the problem. But what we do need is that the window is 8 feet above the ground. And we also need the fact that the ladder needs to be 4 feet from the blazing wall specifically. So we want to know how long the ladder must be to make the rescue. Well, let's find that out. So I'm going to draw a picture here. I'm going to draw a little bit more down here. We have the wall right here. And this wall is how many feet to the window? 8 feet. And we know that this ladder must be 4 feet from the wall in order for it to be considered safe. So given that information, we know that the window to the house is right here, and we have our ladder right here. And the question asks, how long must this ladder be? Or how long does this ladder need to be to reach to the window? Well, making a right triangle out of this, note that this is the hypotenuse of a right triangle. So to figure this out, we can just simply use the Pythagorean theorem and solve for C. Let's say the side length A is 4 feet and side length B is 8 feet. So we're going to have 4 squared plus 8 squared equals C squared. 4 squared is 16, 8 squared is 64. Set that equal to C squared. 16 plus 64 is 80. So we're going to get 80 equals C squared. Now to solve for c, square root both sides, and we get c equals the square root of 80. Now that's not a number that we might be familiar with, so if we plug this in our calculator and get a decimal approximation, we get approximately 8.9 feet. Or you could also round up and just say 9 feet as well. But and there you are.